Okay, cool. All right. So I'll go through the usual demo that I generally give it for any new batch. Okay.
Okay.
So yeah, if you think there's anything that you need to answer, you need me to answer, let me know. I'll just take a pause and answer.
Okay. Okay.
All right. Let's proceed then. Okay. So as I said, my name is Kiran, and welcome to the demo. I have about 10 years of experience in DevOps and site reliability engineering. About me, I'm a passionate technology Kubernetes administrator. My main areas of interest technology are Kubernetes, cloud. I work both on AWS and also a bit on DigitalOcean. So I'm also passionate about automation, um, in the CI/CD, infrastructure as code, and software configuration tools as well, and also about Linux. So that's about me in a nutshell. So let's go through the course details. So what does this course actually cover? If we look at it from a very high, you know, high level, it's about understanding the concepts of IT architecture and software development lifecycle. And obviously, this course deals with AWS, so we understand AWS Infrastructure Services, the IaaS part, and about the operating system administration as well, because that forms the important part of it. And learn DevOps sets. So learn about various DevOps tools. The same resources can be used by multiple persons. You could choose to use it for a longer time or a shorter time. And yeah, the same amount of resources are available for multiple persons. So just because there are 1,000 customers in a day for Uber doesn't mean Uber need to have 1,000 cabs. They can pool the resources together, and these are spread across multiple users. Similarly, just because AWS customers need thousands of servers, they don't need to have 1,000 servers. They use the virtualization software to to divide one machine into multiple virtual machines, and of course these are dynamically allocated and reallocated. For instance, I might have a need of 5 systems up to few hours. Later I might only need 2 systems. So when I release those 3 virtual machines, that capacity is reprovisioned and used by someone else. That's what we mean by resource pooling. And rapid elasticity and scalability. Again, think of a case where you are using your own infrastructure, meaning on your own data center. So if you have to suddenly launch a new offer, for example, let's say you are a e-commerce website like Flipkart or Amazon, and you need to launch your big billion sale, and that means you are anticipating large number of consumers hitting your servers. It could be both existing customers and also new customers. In this case, you need to scale up very rapidly. In a matter of a few days, you need to get hundreds of servers. But doing it on your own physical data center means you have to place an order and they will arrive, and you have to configure them, make them ready. There's a lot of groundwork to be done. But when it comes to cloud, you can scale up in a matter of minutes. So from 10 machines to, let's say, 40 machines, you can scale up in a matter of few minutes. Okay. And elasticity means not only scaling up, you could also scale down. Okay. So for example, the big billion sale is over. You can come back to your original capacity, which is, let's say, 10 machines. So you could delete those virtual machines, back up your data somewhere, and you're good to go. All right. And measured service. So this is another important aspect. Again, I would go back to the Ola example. So back in the day, when you have to negotiate with the cab drivers or auto drivers, it's a fixed price. They would say, if you have to go to airport, they would say, okay, I would charge you 1,000 rupees. They won't tell you how many kilometers you're traveling or how much you're paying for each kilometer. Okay. He says on his own historical data that I would take 1,000 rupees. But today, when you avail a Ola or Uber cab, it will give you exactly how many minutes you traveled, how many kilometers you have traveled, and how much they are charging for each of this minute and each of this kilometer, plus tax. right? So similarly, cloud computing gives you this detailed view of where your bill is going on what are you paying. You're paying X amount for your virtual machines, X amount for your storage, X amount for some other networking devices. So everything is broken up into just like your postpaid mobile bill, if you will. See how your postpaid mobile bill will give you detailed information about where you're incurring cost. Similarly, your cloud providers also give you a very detailed bill. That's what we call as a measured service. Okay, all these things makes something cloud computing. Okay, so before we proceed further, there are three kinds of elements, okay, which make any IT infrastructure, not only cloud, even your on-premise data center. So on-premise data center is a data center which is organized by an individual organization. Let's say something like a Citibank or a JPMC. They have their own data centers. They maintain their own servers. Okay, or it could be cloud. You take anything, but the main elements of any IT infrastructure are compute, storage, and network. Compute means your CPU, RAM, those things which do the computing process. Storage is your hard drives and NAS and SAN, storage area network and network attached storage. All these things form your storage. And next, network, which connects all the things together, connecting multiple machines, connecting the load balancers, firewalls, everything are under the part of network. So you take any kind of IT infrastructure, they are made of these three components. Okay, but depending upon what level of abstraction they have, in the sense how much control you have or how much is hidden from you, you could consider cloud into three kind of three kind of services. One is IaaS, another one is PaaS, and third one is SaaS. So the first one is called as infrastructure as a service, where you don't have to worry about the underlying infrastructure, meaning you don't have to worry about the physical servers, but you can rent virtual machines. Okay, and you can choose what operating system you want to install on top of them. Of course, it's pre-installed, pre-configured, but the maintenance of the operating system and its corresponding things are your responsibility. Okay, so it's virtual machines, yeah, virtual networks, everything is maintained by you. Okay, so the operating system is pre-installed, of course, but any operating system upgrades or security patches, everything has to be taken care by the customer or the end user. And the second type is platform as a service. So in this case, user need not even worry about the operating system layer. He can directly upload his source code and start applying and start running it. For example, let's say you are a developer, you have a beautiful idea about launching a new application. Let's say some collaboration application like Microsoft Teams, but this is for more personal use, like friends can form a group and they can play games, they can watch videos together, all these things. Okay, so but you don't want to go on to the operating system side, the infrastructure side, the networking, security groups, or firewall rules. You don't want to deal with all those things. Then you can use a PaaS provider. In this case, not only the operating system, but he also readily gives you a runtime environment. Runtime environment is nothing but if you want to run your application, you need some kind of software running it. For example, if you're writing your application in Java application, you need to have Java runtime environment pre-installed on your servers. So all these things are taken care by cloud provider. All that you need to take care is uploading your code to his portal or his platform, and your application is ready. Third one is software as a service. So this is a very commonly used, and we all have used in one or the other form. For example, Gmail is a software as a service. Here, you not only worry about you not only not worry about infra, but also you need not worry about the code. Everything is maintained by the cloud provider. You will directly consume the service. Like I said, Gmail or Google Drive are some typical examples of SaaS. Okay, but think of the enterprise situation when you're talking about large organizations. Let's say you might be a big auditing company like PricewaterhouseCoopers or Deloitte or any of those companies, right? So you would your core strength is auditing and financial services, but internally you need to train your folks, you need to train your people in terms of compliance or in terms of your own code of conduct. All these things need to be there in a learning portal. But you don't want to invest in a development team which will extensively work on developing code for a learning management system. In this case, what you will do is you will reach out to someone like LinkedIn Learning or Udemy or Pluralsight, any of these learning platforms, and tell them that, okay, I have about 200,000 employees, 2 lakhs employees. I need you to give us a platform where we will avail your courses, and also we should be able to upload our own courses which are prepared by HR, finance, or whichever team it is. So in this case, you will get the admin usage as a tenant, and you will start giving access to your employees, and they will log in and use the Pluralsight or Udemy. You don't have to worry about the code. You don't have to worry about the underlying infrastructure. All that you need to worry about is access control and any custom code you want to, custom content. Here, you'll not worry about the underlying source code which runs the application. But if you want to upload your own courses, or you want to upload your own, material, you can upload along with the courses provided by Udemy. So that is what SaaS is. Okay. G Suite, for example, Google Suite, which is a SaaS application. Microsoft Office 365 is a SaaS application. Okay. So which cloud providers do we choose? So it depends upon each organization and their style of operation, and their maturity as an IT organization. Okay, if you're some organization which is very well versed with maintaining your own infrastructure, you already have the staff, but you want to move your workloads to cloud, then infra as a service might be a good option because you already have the staff who are well versed with this one. But within that, you still want to make sure some services don't need to have so much of management overhead. You can choose PaaS. Okay, and like I said, and another example for SaaS is, for example, payroll teams. Okay, organizations need not create their own website to maintain their payroll. They can outsource it to some provider like Zoho, for example, or we have so many other providers, right? Like what is that, Workday or whatever. So they will take care of the source code and everything. Do not worry about it. But if it's your core strength, for example, Deloitte or JPMC, which has to prepare their banking applications, they will use their own developers, and they will either choose IaaS or PaaS. And another important thing is there are some pros and cons in each of these areas. For example, in IaaS, you will have a lot of control. You can control from the operating system version to what kind of Java runtime or any application runtime you're maintaining. So you have total control over here, including the networking rules and everything. In platform as a service, you have only the control over the code you're running, not other things. In SaaS, you don't have control over the code or the application. But in SaaS, the management overhead is less. You don't have to have a team to manage this application. In PaaS, it is your development team is working on this. In IaaS, you have both your dev team, ops team, and QA team also working on these resources. Okay, they have their own benefits and pros and cons, like I said. Okay, so that's the overall idea of cloud. And most of the public cloud providers offer you both these kind of services for sure, and some also offer their SaaS services. Okay, so you talk about AWS. AWS has its own EC2 services, VPC services, where you can create your own virtual network known as VPC. Similarly with Azure, you can create your own virtual network, and you can create your own virtual machines and start using them. Or you could use something like, in PaaS, you could use something like Elastic Beanstalk in AWS, where you directly need to upload your code to Elastic Beanstalk, and it will start and choose your not operating system, choose your programming language, in which programming language you have written the application. Okay, right. So let's now, I think that covers good amount of what cloud is. If you have any questions, please feel free to ask.
No, I'm good, Kiran. Go ahead.
Yeah, thanks. So let's take a couple of minutes to discuss about AWS and what it is. So most of you might already know AWS is the leader in the public cloud computing domain. Simply for the reason that it is the pioneer in creating the public cloud. Of course, even before AWS, we had other cloud providers like Heroku and others, or Rackspace, but their tenancy model was different, and AWS came with completely different approach to cloud. Okay, so AWS was launched in March 2006 with one service known as Simple Storage Service, which is similar to your Google Drive. We'll discuss that later. Okay, and in August the same year, Elastic Cloud Compute was launched. Elastic Cloud Compute is your virtual machines on demand. The name was Elastic Cloud Compute. So from then onwards, it's continued to grow, and it is the leader in the public cloud domain, and it is closely followed by Azure, and then of course Google Cloud Platform and other things have come into picture. But yeah, this is still continuing as the leader in public cloud domain. And as of 2021, AWS comprises over 200 products and services, including these belong to various sections like computing, storage, networking, database, analytics, deployment management, mobile developer tools, and many tools for the Internet of Things. In the year 2017, AWS had 17.46 billion in annual revenue, but by the end of 2020, it had grown to 46 billion. You could see it simply tripled over a matter of 3 years. So I put these statistics to help you understand how phenomenally AWS has been growing. No wonder Jeff Bezos is the richest man on the planet. So AWS has 30% of public cloud market share, while Microsoft and Google have about 18% and 9% respectively. But again, Microsoft's statistics are a little, jumbled up because they mix their Office 365 also as part of their cloud. Anyway, okay. But the remaining are, the remaining 50% are by the, or 45% are taken up by the small cloud providers. When I say small, they might be small in cloud. For example, Oracle is a large organization, but their cloud has very limited presence. So is the case with IBM. IBM is a very large organization, but their cloud provider is, not has taken off. But Alibaba and others are DigitalOcean. These things are, vying for that space. Okay. And talking about the notable customers of AWS, NASA and Netflix are notable customers. Excuse me, 1 minute. Okay, so just for the quick comparison about the 4 providers, top cloud providers, you could see that AWS has 33%, then slightly dipped to 31%. It's the amount of market share. How many customers are using? How many customers are using the cloud as a whole? In that share, you could see that AWS has a lion's share of it. And again, as I said, Azure cloud is slightly debatable because they include their Office 365 as also cloud. But still, you could say that this is the second most leading cloud provider, followed by Google and Alibaba and others. So that's the importance of AWS in today's market. And it's continuing to grow. That's obvious. Okay. So if you look at, as I said earlier, infrastructure, cloud is nothing but a collection of data centers. So AWS, when we talk about AWS on a physical layer, it is nothing but a lot of data centers spread across the globe in different regions. As you can see, AWS predominantly has its regions in North America and Europe, and a few in Southeast Asia and China. Good presence in Southeast Asia and China, and also slightly in Australia, but not much in Latin America or South America and Africa. Okay, so these blue things will represent the region, and each of them have multiple locations known as availability zones. Okay, so we'll come to that in a minute. So you could see predominantly they're spread in Europe and North America, and these in the yellow, that means they are coming up very soon. In India, we have one in Mumbai, and another one is coming up in Hyderabad. It's one of the biggest investments Telangana has acquired in the recent past. You might have read it in the news. So that's the presence of AWS across the globe. Okay, and yeah, being a cloud provider means you can launch your resources from any place, irrespective of where you are located. For example, I might be in Hyderabad, but if my client is in the US, I can create the resources for him in the US. Okay, the company might be in the US, the main company might be in the US, but they have a subsidiary or a or a other child what do you call organization, you can create their resources in Europe or Japan or wherever it is. Okay, so it gives you the ability to create resources anywhere, of course. But what makes you choose the resource is another aspect. We'll talk about that. Okay, so availability zone. What is an availability zone? So availability zone is nothing but a large data center, like I've shown you one of the pictures. Okay, so one or more availability zones which are in close proximity are known as is known as a geographic region. So AWS has 80 availability zones and 25 geographic regions across the globe, and they have a lot of other edge locations known as point of presence, where it is used to cache your data to serve it faster to the users. Those are called as edge locations or points of presence. Okay, so one primary difference between AWS and Azure here is, because these both are the leading ones, Azure makes sure that every region has at least 2 availability zones. Meaning, if they launch a region in Hyderabad, that means they're going to make sure there are 2 separate data centers separated by a distance. Maybe one could be in Uppal, one could be in let's say Medchal. The reason being, if someone is creating the resources in Hyderabad region, and due to floods or something, like let's say your Uppal region is affected, so you still have your data center running in Medchal, and you can use infrastructure from that region. So, but in terms of Azure, not all regions have availability zones. That's again another big plus for AWS. All right, moving on. So now let's move on to now we understood what cloud is, and we got a glimpse of what AWS is. Now let's understand DevOps. This has been a really great buzzword all these years. So this is the typical Wikipedia definition. DevOps is a set of software development practices that combine software development and IT operations to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. So again, this is again very theoretical, but on the ground basis, DevOps is not something it enforces these practices. But in practice, our organizations which are still going on to the DevOps path, they have a dedicated DevOps team which take care of the tooling, which work closely with development and QA teams and make sure they create the automation and the tool set to achieve what DevOps is actually intended to do. All right. So if you look at DevOps as a as a structure, as a building, okay, this is what DevOps is actually made of. Okay, so you have your platform, your infrastructure. It could be a cloud. It could be cloud, or it could be a combination of these. Okay, more often than not in enterprise, you might see some services running on your cloud. So no matter what it is, and to build your DevOps pillar, you need some of these main components. You need to make sure your infrastructure provisioning is automated. Meaning, if you have to launch a new application or increase the capacity of your application, you have to make sure your application is provisioned using some automation, not through manually going through AWS website and clicking and doing all that, but through some type of configuration or code, which is called as infrastructure as code. And then you might have tens and hundreds servers, need some prerequisites to be there. Like you might have Linux servers, but on top of it, you need to have some software like, some configuration changes and some software. For example, you need to have Java to run your Tomcat applications. Okay, and also Tomcat application itself needs to be there. Or for your web application, you might need to have IIS if you're a Microsoft .NET user, or if it's an Apache application, you need to have Apache pre-installed, and your developer team is going to build the code, but the prerequisite should be there. For that, we use the software configuration to secure your systems, to install the prerequisite softwares for your code to run. All these have to be automated using software configuration, and of course, monthly patches released by various vendors like operating system, or even your even the Java or other runtime updates. And your developers develop code and they test it, and it has to be released it has to be deployed onto your servers. So to do that, traditionally in the good old days, what they used to do is they used to do the development, test it on their local machines, and then once they know they have made some changes and they know it is working on their machines, they would ask the operations team to deploy that. Then operations team try to deploy it, and it runs into lots of issues, and they go back to development team and says it's not working, and development team says no, it's working on my machines, you figure it out. So that's because on the developer's machine it might be running some version of Java, but on the dev machines it might be running some version of Java. But what CI/CD or continuous integration and continuous delivery does is it makes sure that whenever developers make changes, it's continuously integrated or compiled and built and launched onto the servers, so that every change is already tested and finally you could deploy it into production. So that part is called as continuous integration and continuous delivery. Okay, and finally you have your application, you're launching, you have deployed your code, but as I said, in IT the services could go down anytime. There could be infrastructure failure, network failure, or code issues, anything. But you need to constantly monitor your applications. So no one can manually monitor all the servers or all the applications. So you need to set up some automation around monitoring, and you need to create monitoring and alerting. That's the fourth pillar of your DevOps. And of course, all these are again based on your automation. And of course, we need to, and here when we're talking about infrastructure as code or software configuration, these are not simply some steps we need to do, but these are the code. Just like how you write your Java code or C++ code, you have to maintain these as also code snippets. So to maintain all these, you need a source code management utility. So you use your version control software, and you use a source code repository like GitHub or GitLab or Azure Code Commit. So there are a lot of tools. So source code management is also one of the basis for your DevOps structure. So these together will form your the DevOps practice as a whole. Of course, there are other things that come into picture like your operating system, but that could be also part of your infrastructure. Or you could think about containers, which is both part of your infrastructure and also it's a deployment paradigm. It's how you deploy your application as well. So containers, for example, they could be part of infrastructure or CI/CD as well. Okay, and operating system, as I said, we all need to be familiar with operating systems, and particularly in this course, we are going to focus on Linux. Linux because predominantly enterprise servers use Linux. Not that Windows is not used, but again, yeah, Linux is for many of the newcomers, Linux might be completely new because the servers do not generally have a graphical user interface, so we need to understand Linux operating system as well. So moving forward, if we have to look at this in a structured manner, what is DevOps? Again, going back to the earlier point, it's a culture that aims to create better coordination between development, QA, and operations. What it's not, DevOps is not a single tool or a technology. Like I told you, it's not like a Java or VMware or Oracle software suite. It's a practice actually. Okay, it's a set of practices, and the objective, like I told, it's about building high quality software and maintaining with high availability and resilience. And what are some of the roles very similar to DevOps? As I said, site reliability engineer and cloud ops. These are very similar to DevOps engineer roles. All right, moving on. So if you have to look at DevOps workflow, there is this, I mean, in alignment with the software development lifecycle. So software development lifecycle means not only software, any system has a development lifecycle. For example, even if you're building a metro or a metro rail or even a shopping mall, you have these phases like plan, build, test, implement, and finally monitor. Similarly, if you look at this, DevOps in alignment with the SDLC lifecycle, let's start with build. We'll ignore the plan part. Then you have the configuration part where you configure all the resources, all the prerequisites. Then the continuous integration, continuous, and then monitoring and alerting. And if you look at this from our course perspective, what are we going to learn in each of these aspects? That's what I'm going to show you now. So from the build aspect, how do you automate our infrastructure creation? For that, we are going to use, of course, yeah, we need to use source code management. But for the build, we are going to use Terraform, okay, which is a very popular infrastructure as code tool. It is very popular because it's multi-cloud. You can use it for both Azure, AWS, Google, even Kubernetes, and also your on-premise providers. Each of the configuration part, we're going it's other solutions like Chef or Puppet. So that's why the software configuration management part, we are learning Ansible. And from the CI/CD part, we will use Jenkins, and also we'll take a look at the AWS code commit. Details code version control software, and we'll talk about GitHub. Most of these tools would not have been possible without Linux. So, and Linux is very powerful. And then from finally monitoring and alerting, we are going to focus on, of course, before we go to Amazon CloudWatch, we will learn what monitoring is, what are the metrics, what are the logs, and a lot of other theoretical stuff. And finally, we will implement those things on AWS CloudWatch. Okay, or AWS platform itself. All right, I haven't put containers. So both from the AWS and DevOps side as well. Also for AWS CLI, it's not like ISC tool, but it's an automation tool for AWS. We're going and as we learn about Docker and Kubernetes, how to install Docker, how to create Docker images, and later in Kubernetes, we learn how we can orchestrate all these things together. I think Git and GitHub are repeated twice. Sorry about that. Yeah. And monitoring, we'll understand about what types of monitorings are there, or how do we monitor metrics and logs, and finally, should one have to join this course? So what are the prerequisites? So this is based on the lot of questions that keep coming at the end of the demo. So I put it in a slide. So from the system perspective, you need a system, you need a computer, a laptop, or a desktop, doesn't matter. So it's good if you would have system administrator rights, because you will need to install some software. You need at least 4 GB of RAM, and i3 or a quad core would also be good. I mean, recommended, not a condition, but yeah, otherwise it would be a little slower for you. And from the software part, you could you would need to install Git Bash or Putty and AWS CLI and code editor. You might have to, and mostly all other things we are going to mostly install on cloud only. Maybe you could also install Terraform on your own systems. Okay, from the subscriptions, what subscriptions you need to take? Anyone in this course joining in this course need to take is AWS free tier subscription. Again, it doesn't cost you any money. You have to be, but you have to be careful about the billing. You should delete your resources after the practice is over. And some of the other services you might have to create are GitHub and Freenom and maybe Docker Hub also. These are free services again. Yeah. So from a personal perspective, what do you need to have for this skill? Again, at the skills, I put no prerequisites for this course because we're going to cover from the very basics. And from the personal side, I would, expect for learning time for participation, and also actively participate by asking questions, uh, making making any observations, or you know being active. That's it. So that's about it. And to sum it up, this covers a wide area of topics, and some of the topics we are going in depth also. Tips, I mean, this is intended to both the freshers. Fresher means he could be a totally fresher, or fresher to IT industry also, uh, or also those who are working in IT, like admin jobs or support jobs or project management or anything not entirely technical, or QA engineers. Everyone can benefit from this. So this course offers a lot to learn and upskill, but again, it is again individual enthusiasm of the candidates to learn and practice that takes their career to the next level. That's like a usual disclaimer. Uh, so yeah, that's about it for this demo.
Excellent, Kiran. So end of this course, so I mean, what we can expect from the participants? I mean, I know, like you said, like there are some prerequisites, like they need to have a quality time and all those things. So
Okay.
assuming that they give the quality time, and then spend a lot of time learning these things, practicing and all that stuff. So end of course, what is the expectation?
So the expectation is they would have a fair understanding of DevOps as a job role, DevOps as a practice, and strong, hands-on tools like Terraform and Ansible, and even Docker and Kubernetes. But again, it is a loaded course, Naidu, as you've seen clearly. So I would advise every candidate also the same thing. Pick your topics where your passion lies. Okay. For example, some things are mandatory. For example, cloud, everyone should learn. Linux, everyone should learn. Git and GitHub, everyone should understand. But the other topics like Terraform or Ansible or Docker or Kubernetes, they have to pick their choice and see one or two areas where they want to excel. Okay, and these are all interrelated. And the way I'm going to teach is also incrementally. First, I teach everything as a piece, like and let them understand what a virtual network is. Then I teach about VPC. Then I combine all these things together. Okay, so towards the end, we are going to do a mini project where they should be able to create infrastructure using Terraform, and they should be also able to make servers ready for some code to be directly deployed. Okay, so at least they can do that. They should be able to and also configure those servers so that developers can directly deploy code onto them. But in the CIC, and we are also going to teach CI/CD part also. So they should be able to establish Jenkins servers by themselves, and they should keep them ready for CI/CD. Of course, we are not going into the development aspect. I'll teach them like sample projects that I can find on GitHub and show them how to do CI/CD. But yes, they will be able to become thoroughly good with how to set up as a DevOps engineers, how to set up infrastructure, and the prerequisites. They should be able to set it up.
Okay. So Jenkins, yeah. Hello.
Yeah, go on, please.
Yeah. So you mentioned about the Jenkins. So would that be? I mean, you'd be covering the Jenkins pipelines, or like, is it just the UI configuration?
Oh yeah. So I think I mentioned it here. So again, Naidu, assuming that these people are like totally new to the DevOps concepts, we are going to go step by step. First thing, we're going to create Jenkins server, how to take a human to machine or a CentOS machine and install Jenkins and configure it. And then how do you configure it with your GitHub? How do you get your source code from GitHub? So all these things first, of course, and I also mentioned declarative pipelines. So yes, we are going to learn about pipelines as well.
Great.
Kiran garu, if possible, can you please share course content also? That would be helpful.
I shared it with Lakshmi Garu. Maybe yeah, I'll share it again.
No, in demo at least.
Yeah, I mean,
Can you,
these will
can
be the
you,
parts. I mean, I did not give the hourly breakup, but these are the main topics.
okay.
Yeah, I'll keep this like this.
Yeah, Naidu garu,
Your
Hello, your
voice
voice.
is
Yeah.
have you gone through that one?
and we are not able to hear
Hello?
you. Yeah, now it is
Yeah.
clear.
Okay. One second. Yeah, మీ కోర్స్ కంటెంట్ షేర్ చేశాను ఒకసారి చూసారండి.
చూసానండి.
Okay, thanks. Thank you. Okay, please continue.
Yeah. So Naidu, as I said, I try to kind of, put all these things individually, independently. Then finally, I bring the overall picture, because I assume that people are completely new to IT infrastructure, and trust me, I take a lot of interviews. I hire people. I do projects for a lot of clients, so I interact with a lot of people, so I see where they lack. Okay, in terms of basics. So my focus is, building from the base, right? So giving, when I teach Linux, it's not just like I teach them 10 commands, like, okay, you use these commands to install Apache and you're done. No, but I try to give them the sense of what those things do. And I also spend at least like half an hour to discuss shell scripting. I see like a lot of people and other people, the struggle is, they cannot even write a simple shell script when I ask them to write in an interview. So I know these pains, like and assuming that these people are like, applying with, let's say, 2 to 3 years of experience, I know uh, what expectations recruiters have when they are hiring people like these. So I come from that perspective.
Great.
Yeah. So basics, unless we have basics stronger, తర్వాత ఏం build తర్వాత దానిపైన మనం build చేసుకోవచ్చు.
Yeah. So would you be able to share this deck, Andy?
Yeah. Just give me 1 minute.
Okay.
Sorry, I just stepped out. Yeah, చెప్పండి.
అది మీరు if you can send me the deck, that would be good. So
Yeah, I'll
then
share it.
yeah that's all, Andy. I don't have any further questions.
Cool.
Excellent session.
Thank
Sure.
you, Kiran garu, and also Naidu garu. Thank you
Thank
very
you.
much.
Thank
And
you, Naidu.
for closing it, just let me
Happy
take
weekend.
a chance to tell few things about Career IT, Naidu garu. And Career IT has been established 6 years ago. Until that day, we have been giving trainings on various courses like AWS Devops with AWS Data Science, which are in boom like Hadoop, Salesforce, for an advanced Java full stack developer like that. And thousands of students have been trained. And for every training, we are getting students from APTA, and they have been given special discounts. And most of the people have been satisfied, and we have got good feedback also. I hope that in the coming days also we can expect the same thing, and we can train number of people for APTA also. So we'll expect the positive response in the coming days. Thank you.
Sure, Andy. Thank you.
Thanks. I do have a good weekend.
Thank you. You too, Kiran.
Yeah.
Talk
Bye.
to you soon.